Alright, let's take a look at this problem right here. Look at number 1. It says find the geometric mean between these two numbers. So it says find the geometric mean between 2 and 5. Alright, so this is what we do. Set up a proportion. The geometric mean is the x. Okay, you can make it any letter, it doesn't make any difference, but I'll put x here and x here. And then you got two more spaces, right? That's where the 2 and 5 go. 2 goes here, 5 goes here, and then you just solve. It's pretty easy. Cross multiply. What's x times x? X squared. And then 2 times 5 is 10. How do you get rid of the squared? Square root. So that gets rid of this, right? Square root of that, and that's your answer right there. That's all there is to it. Pretty simple, isn't it? Alright, I think there's a couple of questions like that on the test. Now, you also have, let's draw a triangle. We're going to use geometric mean this time. And here's our situation. You got a right triangle. This is a right triangle right here. And you have a altitude drawn. So that means it's perpendicular to that hypotenuse right there. Alright, here's our situation. Now, on number 3 on this little worksheet thing I gave you, they just make this x. But look, let's make this x, make this y, make this z. Alright, we're going to solve for all 3 of them because on the test I do give you a triangle. It's 3 separate problems. One problem is solve for x, the other is for y, the other is for z. Okay, but it's the same picture, same situation. Let's just use the numbers they give us. Alright, they say 2 and 12. Alright, I'm going to go through this quickly because you can always look at it tonight on YouTube and slow it down if you want. Let's solve for x first. So x is a geometric mean. Remember, all 3 of these things are geometric means. The x, the y, and the z. They're all geometric means. Now, they're different numbers, but they all represent a geometric mean. And how do you do geometric mean? You put the geometric mean diagonal to each other, and you put the 2 numbers that is between diagonal to each other. Everybody got it? So let's say I'm trying to solve for x. So x is a geometric mean, so I put x here and here. Now, the thing that you have to know how to do, this is really the only thing that you really have to know, is between what 2 numbers is this the geometric mean? Between what and what? Is it between the 2 and the 12? No, it's between what? The whole thing. That's right. The whole thing, which is what? 14. So this side is the geometric mean between the whole thing, which is 14, and which number? 2. The number that's closest to that side right there. That's basically all you have to remember on this. It's pretty easy, isn't it? Cross multiply, x squared, and then 14 times 2 is 28. I'll just let you leave it square root of 28. That does simplify, but if you want to just keep it the square root of 28, that's fine with me. Alright, got it? Okay. Let's do y. Y is kind of the same thing, except it's just on the other side. So y is also a geometric mean. Between what and what? 12 and 14, that's right. Or 14 and 12, either way. Cross multiply, y squared, and then 14 times 12, I have no idea what that is. I should know, but turn it on. 14 times 12, that's 168. If you just want to keep it 168, I'm fine with that. Take the square root of it, just leave it like that. Pretty easy, isn't it? Yeah, you just have to remember that these are geometric means in between which 2 numbers. What about z? Yeah, z is a geometric mean. The altitude is a geometric mean between the 2 segments. Not the whole thing, just the 2 parts of the hypotenuse. Okay, so you got 2 and 12. Cross multiply, z squared equals what? 24. Square root both sides, and there you go, square root of 24. These do simplify. If this was, I don't know, I'm just not making simplifying. Okay, I probably should, but I'm not. Alright, we good with that? Pretty easy, right? Go back and watch it tonight if you forget. Alright, let's take a look at number 4. Now, on the test, it probably won't be inside of a rectangle like that. I'll just do the part that's pertinent to what we're trying to do. So basically you have a right triangle that looks like that on number 4. This is 60, this is 20, and this is x. Alright, I don't tell you like which method to use to solve for this. you have to figure it out. What's the best way to solve for x in this situation? Pythagorean theorem. Why? Because you have a right triangle, okay, and you have two sides of a right triangle. If you have two sides of a right triangle, that means you use Pythagorean theorem to find the third side. Everybody got that? Alright, so what is it? It's x squared equals, remember the hypotenuse is always the one that's sitting there by itself. X squared equals what? 60 squared plus 20 squared. And then how do we solve for x? Get rid of that squared, so what do we do? Square root all that. Now look, that square root does not cancel these squares out. You still got to square those two things, add them up. So let's chuck them in a calculator and let's see what we get. We have 60 squared plus 20 squared equals, okay, that's 4,000. And then you just take the square root of 4,000. You should be able to do that in your head, but we'll put it on the calculator. Oops, what am I doing? 0. 4,000, yeah. Well, actually, 40, yeah, well, nah, maybe not. I was thinking 400. I mean, maybe you could, but we'll just do it in the calculator. So there you go, 63.2. Now, I'm not saying you should have got 63.2 in your head. I'm saying it would be the square root of 40 times square root of 100. So that would be 10 times the square root of 40. If you do the square root of 40, it's 4 times 10, so it's 2, so it's 200 square root of 10. So let's see, 200, why do I keep pushing the 1 there? 200 times the square root of 10. Oh, I was off one. What did I say, 200? I probably meant to say 20. That's right, not 200, but 20. And that should give you that, right? Yeah. Anyway, just thinking out loud. Okay, 63.2 is what it should be. X is 63.2. Then you're done. That's it. That's all you got to do. Throw it in a calculator, get a number, you're good to go. Make sense? All right. Problems on this little review thing I gave you today, probably a little more difficult than what's on the test. So I'm trying to find problems that are a little more like what's on the test. Okay, let's do this. I'm kind of doing number 6. Well, I am, but I'm not really drawing a square and stuff. But they tell you basically have an isosceles triangle, right? They tell you this and this are equal to each other. Everybody see that? And then they want to solve for x, which is one of the sides. And they tell you this, which is 22. Alright? So how are we going to do that? What's the easiest way to do this? Okay. First of all, what kind of angles are these? What is it? Why 45? Yeah, the two sides are equal. Okay, if the two sides are equal, the two opposite angles are equal. And that means these two angles add up to 90. They're both exactly the same, so you split them in half, and so that's 45, 45, 90. You should know that, right? When we talked about the 45, 45, 90 triangles, they're isosceles triangles is what they are. And we have a relationship. Look, this is one of the legs. Let me write down the relationship. The hypotenuse is equal to the square root of 2 times one of the legs. Now, if they told you the leg, it would be real easy. You just take that leg and you multiply by the square root of 2, and that's your hypotenuse. That was the easy part. You might have one of those on the test, okay? Where you take the leg, whatever it is, let's say it was a 5. I'm just making this up, okay? Forget the 22. Let's pretend this is a 5. So what would the hypotenuse be if this leg was 5? If the leg was 5, what would the hypotenuse be? Just 5 times the square root of 2. That's right. That's all you do. Write it like that. Don't even need to put that in a calculator. Just keep it 5 square root of 2. In fact, on the test, when it's a 45, 45, and 30, 60, 90 triangle, in the instructions it actually says write it as an exact, simplified answer, which means I don't want a decimal out of it. You hear me? So if I give you a 45, 45 right triangle, right? So if that's 45, and I say that's 5, and I ask you to solve for this, what should this side be? It should be what? 5 square root of 2. I would accept no other answer besides that. That's it. You got it? Don't punch it in a calculator and give me a decimal. In fact, on the test, the instructions specifically say no decimals. Okay? So this is what your answer would be. But this is a little different. This time they tell you the hypotenuse. They tell you the hypotenuse. and you have to find the leg. Well, how do I find the leg? I don't multiply it by the square root of 2 because I don't know what it is, do I? What do? I got to get rid of the square root of 2. How do I get rid of it? I divide, right. If I know the leg, I would multiply by the square root of 2 to get the hypotenuse. If I know the hypotenuse, I would what? Divide by the square root of 2 to get the leg. So this is going to be 22 divided by the square root of 2. Now we've talked about this. This is not simplified. This is not simplified right here. Why is this not simplified? Square root on the bottom. And we've discussed this, haven't we? 22 over the square root of 2. How do I simplify it? And the instructions specifically say to simplify your answer on this. That's it. Multiply the top and bottom by the square root of 2. Exactly right. And let's see what we get. On the top, we just get 22 times the square root of 2. On the bottom, what does that come? It's just a plain old 2. Do we just leave it like that? No, we can simplify a little bit more. What happens here? 2 goes into this once, 2 goes into this 11 times, so that would be what? 11 square root of 2. That's how I would want you to write your answer for x. Went through it a little quick, but you can always go back tonight and look at it and slow it down. Or not really slow it down, but, you know, watch it 3 or 4 times. Got it? Alright. Let's see what else we got. Let's do this. I'm kind of taking number 8. I'm basically doing what they're doing. I'm just making it a little bit easier to see. Alright, without all the other junk. I'm kind of separating this one triangle out of everything. Let's call this X. Wait a minute. Before I do that, tell you what, let's not do this one just yet. Let's put that one on hold. Actually, let's just get rid of it. Let's do this one first. Watch. This looks like this. This looks like this. Looks like maybe like that. Let's drop this one down so it touches. Okay, that's pretty good. That's a right angle right there. This is 60 degrees and this is 30 degrees. Before even putting numbers in here, let's go over what our relationship is on a 30, 60, 90 triangle. Let's do the hypotenuse first. Remember that? The hypotenuse is what? Remember the relationship? 2 times what? Not just the legs are different sizes here. The short leg, right? It's the short leg, and then I just write short, okay? And then the long leg, there's a relationship between the long leg. What's that? Square root of 3 times what? The short leg. Remember, they both have to do with the short leg. The short leg is the important leg here, right? What do they tell you? They tell you this value right here, which is 4 square root of 3. Alright, that's what this length is right here. So what do you think? Well, what did they give us? Did they? They gave us the hypotenuse. It's across from the 90-degree angle. So they give us the hypotenuse, so I should be able to find the short leg. If they give me the hypotenuse, how do I find the short leg? Do I multiply this by 2? Divide it by 2, because this is the longest side, isn't it? Alright, if I want to find the short one, I don't multiply it by 2, would I? That would make it even bigger, wouldn't it? Alright, so what do? Divide it by 2. Divide this by 2. That's easy. 4 square root of 3 divided by 2. That goes once, that goes twice. So what is the short side? 2 square root of 3. So I got the short side. What about the long side? This one right here, that would be the long side. How do you know that's the long side? Just because it looks like the long, I should say long leg instead of long side. How do I know that's a long leg? Because it's opposite the 60 angle, the 60-degree angle. That's right. Okay, out of the 2, that's the longer leg. So what's the relationship? Long leg is what? The square root of 3 times the short leg. Well, if this is the short leg, 2 square root of 3 is the short leg, what do I do to it? I divide it? It's right here. The short leg is it's the short leg times the square root of 3. I'm trying to find the long leg, right? I know the short leg, so I multiply it by the square root of 3. So what is that? 6, right, because square root of 3 times square root of 3 is just a plain old 3. 2 times 3 is 6. So that's what the longer leg is. There you go. They give you this. We found the short leg, and we found the longer leg. So you need to know that. Everybody got it? They're exact answers too, aren't they? They're exact and they're simplified. This is not a decimal. It's not an approximation. It's exactly 2 squared root of 3. This right here is not an approximation. It's exactly 6. Everybody got it? Okay. Go back and watch it again if you need to. Let's look at the very bottom one. We kind of skipped this lesson, but I think we can figure this out, because this has to do with our trig functions. Actually, let me do a regular trig function first, and then I'll do the word problem, okay? Let's draw a right triangle. We went over yesterday law of sines, law of cosines, right? Okay, so we don't need to do that today. And when's this over? 12:20. Okay, I got time. Alright, let's see. This is 18 degrees. So this is not one of our special triangles, is it? This is not 30, 60, 90. It's not 45, 45, 90. I had somebody in my other class, we were doing the same thing. And, I don't know, I had a triangle. And the hypotenuse was like 10, and the short side was 4. And she said, well, I thought the hypotenuse was always twice as big as the short side. But guess what? It wasn't a 30, 60, 90 triangle. Okay, is that always true about every single triangle in the world? No, the hypotenuse is not always twice as big as the short side. All right, it's only true on a 30, 60, 90 triangle. So you got to, you know, she heard stuff, but she didn't hear it the right way, right? So that's what you got to make sure you understand. So that's x, and this is 9.2. And we want to solve for x. So we're not going to do the thing where we say the square root of this times the short side, the square root of 3 times the short side, or the square root of 2 times the leg, or anything like that. This is just 18 degrees. It's a right triangle. We don't have to use law of sines or law of cosines like we did yesterday. All right, we're going to use just our regular trig functions. Do you remember our 3 trig functions? Sine, cosine, and tangent, and we remember them by this: so, ka, toa. All right. So those are our trig functions. So we have to figure out which one of these do I have to use. Well, if I'm using this angle right here, look at the 2 sides that they give me. What is this side right here, the 9.2? What is that to this angle? It's adjacent. Okay, so we've got adjacent. What is this? This is hypotenuse, isn't it? AH, Aaron Hamrick. There we go. So what is what trig function do we use up here? Cosine. Cosine, it's adjacent hypotenuse. Adjacent hypotenuse. It's the cosine. Alright, so it's the cosine. Everybody got it? Alright, so it's the cosine. That's what we use. Now, how do we use it? Once we figured out we use the cosine, we take the cosine of the angle, which is 18, is equal to the adjacent. Which side's adjacent? 9.2 over the hypotenuse, which is x. Now you got to know the math, okay? You got to know the algebra on how to get x by itself. How do you get rid of that x down the bottom? Multiply both sides by x. So really, basically, remember we said this, did we say it yesterday or the other day? Basically, you just switch places with these things, right? Because the x is going to go on the top, cosine of 18 goes on the bottom. Brian, snap out of it. Pay attention. So x equals 9.2 divided by the cosine of 18. Do you see the math? It's not that hard, is it? Right? We've done these several times. Take the x, put it on the top, cosine of 18, put it on the bottom, boom, throw that in the calculator and you're good to go. So it's 9.2 divided by, oops, let's try that again. 9.2 divided by cosine of 18. And it's about 9.7, okay? So approximately 9.7. There you go. That's what that is right there, 9.7. Make sense? Yep. I think so. Good, good, good. Let's do this one. Here's another situation. This is kind of like I'm taking off from number 10. Alright, it's kind of like number 10. I'm just giving you a little more basic information than what they give you. we're going to say that's that. I'm going to call this x degrees. I'm going to call this 15, and I'm going to call this 40. Okay? Well, what do you think? Use trig function, right? Because it's a right triangle. I'm not trying to find a side, am I? Alright, so I'm not going to use Pythagorean theorem, because I don't care what that side is. Alright, that's not what I'm looking for. I'm trying to find an angle. Trying to find an angle. So I'm going to use a trig function. Sine, cosine, or tangent. I'm not going to write them down this time. We should have them memorized by now. So what are we going to use? This is opposite. This is adjacent. So which one's opposite and adjacent? The tangent, right. So it's the tangent of what? Of x. You always take the tangent of the angle. Don't take the tangent of the side, either one of these. It's the tangent of this angle right here. Equals. Opposite over adjacent. So it's what? 40 over 15. How do you get x by itself? Inverse tangent. Right. So x is the inverse tangent of 40 over 15. I mean, I guess you could reduce this if you wanted to, but there's really no need since you're using a calculator anyway. Alright, so what I would do is hit second function tangent of 40 over 15. There you go, 69. It's a angle, so we'll just say it's 69 degrees. And that's what this angle is, right there. Alright, so that's an inverse tangent, an inverse function. You need to know how to do those. All these things I've been doing, you're going to see something, some kind of a, a problem like this, like the ones I've been giving you. All right, let's take a look at number 11. 11 is a little word problem, and I actually do put a word problem on there. All right, it's not hard at all. Let's take a look at it. It says a 30-foot tree. Now, I don't have to draw a nice pretty tree, but it casts a shadow. Casts a shadow where? Along the ground, probably, right? So look at this. Everybody watching? Judy, you watching this? So look, there's my tree, skinny old tree, right? And here's my ground. Now you do have to make some basic assumptions. We're assuming the tree is not growing crooked, right? We're assuming that the tree is perpendicular to the ground, right? And this is our ground right here. And I think trees normally do grow perpendicular to the ground. Actually, that's not necessarily true, do they? Because if on a hill, the tree does up. Right, they go up towards the they go up towards the sun, I think, right, or something like that, or it's to the center of, it's to north, I think is what they do. Anyway, we're making an assumption this is horizontal, all right, and this is vertical. I think that's a pretty decent assumption to make, all right. Now it says a 30-foot tree. So which one is the tree? That one. So that's 30 feet. And again, this is an assumption that we're making that the tree is perpendicular to the ground. It casts a 12-foot shadow. Which one is the shadow? Is this the shadow, that length right there? If you look on the ground, you're standing there, you look, where is the shadow? The shadow is being cast on the ground, isn't it? Right? So this is the shadow right here, and it's a 12-foot shadow. Now, I didn't really draw this to scale, did I? That's 30 and that's 12, but that's okay. It doesn't really have to be. As long as our numbers, right, as long as we use the numbers the correct way, we're fine. The question says, find the angle of elevation. Here's the angle of elevation. The angle of elevation is from the horizontal. Everybody watching? Look up here. Look up here. Everybody up here. It's from the horizontal up. Angle of elevation. To elevate, you do what? You go up. Okay? You follow me? So it's from the horizontal up. That's the angle of elevation. That's what we're trying to solve for, and I'll just call it x. I took that all from those words on number 11. Everybody see that? It wasn't hard, was it? You're going to have a problem very similar to this. All right? It might not be a tree and a shadow. It might be something else. You got it? All right, but it's very, very, very close to this problem. They might give you a little different information. They might tell you the angle, right? And you have to find one of these sides. You got it? But they'll give you enough information to be able to solve what you're supposed to solve for. But you draw your picture out just like this. It doesn't have to look like a tree. It doesn't have to look like a person standing there looking up, right? You just draw the straight lines. That's all you need. Now, we just basically did this problem earlier. How do we find this angle right here? Well, look at what we're given. This is opposite and this is adjacent. All right, so again, we use the tangent. Same exact thing as we did before. So the tangent is the opposite over the adjacent. Get rid of the tangent by taking the inverse tangent Looks very familiar, doesn't it? We just finished doing one that was almost identical to this. So it's 30 over 12. Oh, I'm sorry. Let's clear that. Let's go inverse tangent. Inverse tangent of 30 over 12. 30 divided by 12. All right. Now look, on your if you're using a TI-30 and not this graphing calculator, you would hit 30 divided by 12 equals, and then you would hit second function tangent, and that would give you your answer. Okay. On this calculator, I hit the second function tangent first, then I put 30 over 12. Make sure you know how to operate your calculator. There you go. So that's about 68 degrees. That came out close to the other one too, wasn't it? So this angle right there is 68 degrees. That's it. That's the angle of elevation. Now, that doesn't look like a 68-degree angle, does it? But again, I wasn't real careful when I drew the measurements out. But it's fine. It's still the right answer. Just my picture's a little off. I believe that's about everything, at least on sections 1, 2, and 3 on this chapter. I don't think I left anything out because the other chapter, the other sections was law, sines, law, cosines, right? And what else did we do yesterday besides law, sines, law, cosines? The what stuff? Say it again? Oh, okay. Yeah, so we hit geometric mean today, and we might have even repeated some stuff from yesterday. I can't remember, but that's alright. That won't hurt. Everybody good? Yeah, I think that's it. I think you're covered for this test. Go over it tonight on YouTube if you need it. Do what for extra credit? Nah. We did all the important ones together in class.